Hi friends, today we will discuss about the topic of power sources. First of all, the question, what is power source? The definition of power source simply a power source is any device or system that provides energy to operate electrical or mechanical devices. In simpler terms, a power source is the source of power. A power source is a system or component that supplies energy such as electrical, chemical, or mechanical energy to power various devices or machines. Common examples include batteries, solar panels, generators, and power plants. Primary energy sources take many forms, including nuclear energy, fossil energy like oil, coal, and natural gas, and renewable sources like wind, solar, geothermal, and hydropower. These primary sources are converted to electricity. It means primary energy sources take many forms. It means there are different kinds of natural resources that provide energy in its raw form. Examples: these sources are found in nature and are not yet converted into usable forms like electricity. Including nuclear energy. It means one type of primary energy comes from nuclear reactions, mainly from splitting atoms, nuclear fission, used in nuclear power plants to generate electricity. Fossil energy. It means like oil, coal, and natural gas. Oil, a liquid fossil fuel used in vehicles, industries, and power plants. Coal, a solid fossil fuel burned to produce heat and electricity. Natural gas, a gaseous fossil fuel used for heating, cooking, and electricity generation. Renewable sources like wind, solar, geothermal, and hydropower. Wind energy means captured using wind turbines to produce electricity. Solar energy means captured from the sun using solar panels. Geothermal energy comes from heat inside the earth. Hydropower generated from the movement of water, usually through dams. These primary sources are converted to electricity. It means the raw energy from sun, wind, fuel, etc. is processed using technology like turbines, engines, or generators to produce electricity, which we use in homes, industries, and devices. A secondary energy source which flows through power lines and other transmission infrastructure to your home and business. It means a secondary energy source. This refers to energy that has been converted from a primary energy sources. For example, electricity is the most common secondary energy source which flows through power lines. This means after being generated, electricity travels through high voltage power lines for distribution. Transmission infrastructure includes transformers to adjust voltage, substations to route power, and distribution lines to reach homes and business. To your home and business. The final stage delivers electricity to consumers for use in lighting, appliances, machines, etc. In simpler terms, primary source means found in nature like coal, solar, and wind. Secondary source means converted from primary source like electricity. Electricity is a secondary energy source because it's made from other energy forms and then transmitted to users. Next, we will learn about the DC sources. DC sources are sources of electrical energy that provide constant voltage and current in one direction only. It means types of DC sources. Batteries like lead acid batteries, lithium ion batteries, and alkaline batteries. It is commonly used in mobile phones, cars, and remote controls. DC generators. It means mechanical energy is converted into direct current electricity. It is used in older power systems and backup generators. Solar cells means photovoltaic cells. This is convert sunlight into direct current used in calculators, streetlights and solar panels. Power supplies means DC adapters convert AC from the wall outlet into DC used in computers, routers and chargers. Characteristics of DC source, that is, current flows in one constant direction. Voltage remains steady over time. Common in low voltage electronic devices. DC sources refer to sources of electrical energy which are associated with constant voltage and currents. It means DC stands for direct current. These sources supply electricity where the flow of current is in one direction only. DC sources are devices or systems that provide electrical power. Examples include batteries, solar cells, and DC generators. Which are associated with constant voltages and currents. These sources deliver a steady voltage, doesn't change with time. The current also flows consistently in a single direction without fluctuation. This is different from alternating current, where voltage and current vary over time. In simple terms, DC sources give a steady and unchanging flow of electricity, unlike AC sources where the current and voltage go up and down. A DC power supply can be constructed as an electronic circuit operating from the AC main electricity supply and designed for purpose. It means a DC power supply. This refers to a device that provides direct current output, commonly used to power electronic gadgets, computers, chargers, etc. A DC power supply can be built using electronic components such as diodes, transformers, capacitors, and regulators. These components convert AC into DC and stabilize the output. The input power comes from the standard alternating current electricity from wall outlets, usually 110 volts or 220 volts. The circuit is designed to take this AC power and converts it into usable DC power. The circuit is customized for specific applications such as mobile chargers, LED drivers, laboratory DC supplies, and computer power supplies. This means the voltage and current ratings are matched to the needs of the device being powered. In simple terms, a DC power supply uses AC electricity from the wall, runs it through a special circuit, and gives out DC electricity tailored for a specific job. The image displays a graph representing direct current DC. Direct current is the unidirectional flow of electric charge, meaning the current flows in only one direction. Graphical representation. As shown in the image, DC is graphically represented by a straight line indicating a constant voltage and current over time. Characteristics. Unlike alternating current, DC maintains a constant voltage and current, making it suitable for applications requiring stable power. Common sources of DC include batteries, rectified sources, and solar panels. It's used in various devices from mobile phones to electric vehicles. Examples of some sources of direct current are cells, DC generators, etc. It means introduces a list of items that provide direct current. Some sources of direct current refers to devices or components that produce DC electricity, electricity that flows in one direction. Cells like dry cells or batteries and DC generators are common sources of DC power. Other sources like solar panels or photovoltaic cells, DC power supplies, and fuel cells. In simpler terms, examples of direct current sources include chemical cells, means batteries, DC generators, solar cells, and DC power supplies. Devices like dry cells, dry cell batteries, car batteries, radios, and televisions work only with direct current, as they have built-in circuits that convert the AC supply into DC. It means devices like dry cell batteries, car batteries. These are all sources or users of DC power. Dry cells provide small DC power. Car batteries supply 12 volts DC for vehicle electronics. Radios and televisions. These electronic devices also operate on DC internally, even though they are plugged into an AC wall supply. The internal circuits of these devices require DC electricity to function properly, as they have built-in circuits that convert the AC supply into DC. These are usually rectifier circuits or power supply units inside the device, that is, take in alternating current from the power outlet, convert it to direct current for internal use. In simple version, even though devices like TVs and radios are plugged into AC outlets, they convert that AC into DC inside because their components need DC to work. DC current is the current that does not change its direction with time. It means DC stands for direct current. It refers to an electric current that flows in one constant direction. The current that does not change its direction with time. Unlike alternating current, which reverses direction periodically, DC flows steadily in one direction. In simple version, DC current flows in one direction and stays the same over time. Next, we will learn about the AC sources. An AC source is a source of electrical energy that produces alternating current that changes direction periodically over time. It means AC stands for alternating current. The flow of electric charge reverses direction at regular intervals. The voltage also varies in a sinusoidal manner. Direction and magnitude change with time. Unlike direct current, which is constant, alternating current increases and decreases in magnitude and switches direction. Standard frequency. It means in most countries 50 Hz cycles per seconds. Example India and Europe. 60 Hz cycles per second. Example USA and Canada. This means the current reverses 50 or 60 times per second. Common examples of AC sources are AC generators, mains electricity supply, and inverters. Advantages of alternating current sources: easy to transmit over long distances with less power loss. Voltage can be easily stepped up or down using transformers. Used for powering homes, offices, and industries. In simple definition, an AC source is a device or system that provides electricity where the current keeps changing direction with time. AC is produced by an alternating EMF, which is generated in a power plant. It means alternating current is a type of electric current that changes direction periodically. EMF stands for electromotive force, means voltage. N alternating electromotive force means the voltage also changes direction, positive to negative and back in a regular pattern, which is generated in a power plant. In power plants, AC generators or AC alternators rotate magnetic fields within coils, creating alternating electromotive force. This is the source of the AC electricity sent through the grid to homes and industries. In simple version, AC is created in power plants by generators that produce alternating voltage, means electromotive force. If the AC source varies periodically, especially in a sinusoidal manner, the circuit is called an AC circuit. It means if the AC source varies periodically, alternating current means the current changes direction and magnitude over time. Periodic variation means this change happens in a regular cycle. Example, 50 or 60 times per second. Especially in a sinusoidal manner. In most cases, the AC waveform is sinusoidal, means sine wave shaped. Sinusoidal AC is common because it is efficient for transmission and generation. The circuit is called an AC circuit. A circuit connected to such an AC source that varies sinusoidally or periodically is called an AC circuit. These circuits are analyzed differently from DC circuits due to the changing current and voltage. In a simple version, when an AC source changes in a regular wave like pattern, like a sine wave, the connected system is called an AC circuit. Examples include the commercial and residential power that serves so many of our needs. It means alternating current is the type of electrical power that is used to power most of the devices in homes and businesses. This includes common appliances like televisions, refrigerators, and washing machines. AC is also standard for the electrical grid and building wiring. In simple version, AC sources are used in many places. Examples include power used in homes means residential power. Power used in offices and factories means commercial power. These serve many of our daily needs. The sources are hydroelectric power plants, thermal power generators, and nuclear power generators. AC generators produce alternating current. It means the sources are hydroelectric power plants, thermal power generators, and nuclear power generators. List the main sources of energy that generates AC power. AC generators produce alternating current. Explains that these sources use alternating current generators to produce AC electricity. In simple version, hydroelectric, thermal, and nuclear power plants are major sources of electricity. These plants use AC generators to produce alternating current. This image displays a graph of alternating current with current on the vertical axis and time on the horizontal axis. The alternating current changes direction periodically. The wave goes above and below the zero line, showing the current reversing direction. Horizontal axis, labeled as time. It shows how current changes with time. Vertical axis, labeled as current. It shows the value of current at any moment, where vertical axis means y axis. Sine wave shape. The smooth wave represents a sinusoidal waveform typical of AC power. It repeats in cycles. One complete cycle includes a positive and negative of. Point zero. It is the origin where both time and current are zero. The current starts increasing from zero, goes to a maximum, comes back to zero, becomes negative, and so on. Uses of this graph to understand how alternating current varies with time, to compare with direct current, which is a straight line, to explain frequency, amplitude, and phase in a alternating current circuits. This is our brief explanation of the power sources. Thank you very much. Padmam MM.